With three capacitors, each of the capacitance 2 microfarads are connected to a cell 6 volts. The potential at A. So when plate of a capacitor is connected to earth and it is completely discharged, its potential is 0. So let us say this point VA minus V0 is, that is VA minus 0, Q we don't know, C is 2 microfarad. Here 2 microfarad, like the three capacitors are connected in series. Effective capacitance is equal to 2 by 3 microfarads. So charge here is 2 by 3 into voltage 6 volts, 4 microcoulombs. Then VA will be in series, same charge flows across each and every capacitor. So that is 4 by 2. We get 2 volts. Here graph between terminal voltage and current flowing through the same cell as shown in the figure. Here there are three parts. One is AB, another is BC, another is CD. So before that, what is terminal voltage? When battery is not connected to a circuit, then electric field exists inside the battery due to accumulation of positive charge at one place, negative charge at one place. Then EMF is equal to potential difference between AB. Right. When battery is connected to A, this is battery connected to a source or charger. So current flows through this. At this point, potential VA. So the potential difference VA minus VB is equal to. So here it is VA minus E. It is internal resistance, battery internal. That means potential difference, in fact, more than EMF. Right. So portion AB indicates charging of a cell. And charging, potential difference across AB will be more than its EMF. So here, this battery is connected to a circuit, right? Some resistance. Resistance can be bulb or anything, fan or anything. Here VA minus VB becomes E minus IR. So when resistance is connected to a battery, current flows through this resistor. Its EMF, its terminal voltage obviously becomes less. So that is BC indicates discharging of a cell. Here BC indicates discharging of a cell. In the last case, that is CDs. Here CD means can potential difference be less than EMF? So that is VA minus VB must be negative. This is possible when battery is damaged. So dead battery get negative polarity. So option 4 is correct. And here he is given a graph of magnetic field versus distance. Suppose here, if you consider a circular coil of radius A, maybe 1 turn or maybe having n turns, we don't know. Let us assume that it's 1 turn, like that n turns are there in the coil. Then we have a derived formula, that is magnetic field at a distance, right? X from the center of the coil at this point, magnetic field mu naught, here I current passes through it, mu naught n by a square plus x square power 3 by 2. Ni a square by 2 times a square plus x. So this a square plus x square is released when x is 0. So that is, if x is not 0, a square plus x square will be more. When a square plus x square is more, denominator is more, magnetic field becomes less. Since x is replaced by minus x minus x whole square, there is no change. So curve will be obviously symmetric about y-axis. And when a square plus, that is at x is 0, magnetic field at O is greatest. The suitable graph, symmetric and greatest, will be this. As x increases, magnetic field decreases. Here, question number 21. So we changed the question. This question is, in fact, Doppler effect, which is not there in the syllabus. So the refractive index of medium is mu. We have a formula where epsilon r is dielectric constant, that is given as 2, and relative permeability given as 1.2. So what he is asking is refractive index, that is 2 into 1.25, 2.56, which is 1 point. Question is, he given epsilon r, he given mu r, and he is asking refractive index. So here epsilon r is given as 2, and relative permeability he given it as 1.28. Here it is. First of all, what we have to find out is magnetic moment. Magnetic moment of a magnet is denoted with capital M pole strength into 2L. Here 2L is effective length between poles. Now, so magnetic moment here is that is M into effective distance is R. But we have to find this in terms of capital M. So here he told that these are all radius, so equilateral triangle 60 degrees. This angle becomes 360 minus 60, it becomes 300. For 360 degrees, length becomes 2 pi r. So for 300 degrees, 2 pi r by 360 into 300, 6 5s, that is effective length here is 5 pi r by 3, which we are considering it as 2L. Then in place of R, I will write a 6L by 5 pi. So magnetic moment is M into 2L. M into 2L here is 5 pi R by. Magnetic moment is MR, that is 6 ml by 5. So 3 times 2 ml by 5 pi. 2 ml is capital M, 3 m by 5 pi is the answer. Here, ideal gas compressed adiabatically. So we have for adiabatic process, PV power gamma is constant, but here it is related to temperature and volume. So PV here is nRT. In place of P, I will write nRT by V. That is TV power. After substituting, you get constant. T1 V1 power gamma minus 1. And he given T1 as 27, that is 300 Kelvin. V1 V1 by V2, gamma minus 1 is T2. So adiabatically compressed to, that means V2 by V1 is 8 by 27 of original volume. Right. So original, that is 300 into 8 by 27 is 2 by 3 whole cube. Gamma value 5 by 3 minus 1. So T2 will be 300 into 4 by 9. By 27. I'm sorry, here it is a small mistake. 300. V1 by V2 will be 27 by 8. Gamma is 5 by 3 minus 1, which is 300 into 3 by 2 whole cube into 2 by 3. And that is T2 will be 300 into 9 by 4. 75. 675. Then rise in temperature will be originally how much? 300 Kelvin. So rise will be 375. Second option is correct. A force acting on the block. So work done here is F bar dot AB bar. F here is 2I plus 3J minus K. AB here is, so initially it is at I plus J. Finally it displaces to I minus J plus K minus of I plus 3. I get cancelled. 2I plus 3J minus K dot minus 2J plus K. Here it is minus 6 minus 7 joules. For a process of monatomic gas pressure, PV power minus 3 is constant. So for isotropic process, PV power N is constant. So the work done for isotropic process, so molar specific heat of gas is C equal to Cv plus R by this. So for monoatomic gas, Cv is equal to R by gamma minus 1. Gamma here pi by 3 minus 1, 3R by 2. C becomes Cv plus R by 1 minus N, 3R by 2 plus R by 3R by 2 plus R by 4. Where it is 6R plus R, 7R by 2. If two bodies, a ring and disc, are rolled down without slipping from an inclined plane of an angle theta, what will be the ratio of acceleration of center of mass? So acceleration of center of mass of rolling body over an inclined plane. Yes. Here K is the radius of gyration per ring. Mr square is mk square. K square by r square is 1. For a disk, mr square by 2 is mk square. K square by r square is half. Here it is g sine theta by, for ring, this is 2. For acceleration of center of mass for a disk, g sine theta by 1 plus half, which is 2/3 g sine theta. He is asking ratio of acceleration of center of mass of ring and disk. That is g sine theta by 2, 2g sine theta by 3, which is 3 by 4. Here it is. A stretched wire is fixed at both ends. Standing waves are produced. So the ratio of energies, so ratio here energy of stationary wave is equal to a square mu square omega square mu L. Here, first one, this is a sine kx omega t. So that means a square is 36. So omega here is 20. So 20 square. So this is mu into L is nothing but mass per unit length, let us say 1. Now wire is not changed. So energy of another stationary wave is 4 into here omega is 40 and same wire mu L will not change. So E1 by E2 is equal to 36 into 20 square mu L by 4 into 40 square into mu L. So 20 square means here it is 36 by 16, which is K by 4. So value of K is 9. The RMS, so here for AC current, the current varies as like this, which is I naught sine omega t. The peak current is this, peak voltage is equal to I naught R, which is 20 resistance given 200. RMS voltage is V naught by root 2, 200 by root 2, which is 100 root 2. A ray of a ray incident on a glass plate at an angle 90, this is surface, at an angle 90 degrees from the surface means normal incidence. For normal incidence, I is 0, angle of refraction also 0. Answer is 0. Here body is projected vertically up with a speed 25 meters per second. Find the distance traveled by body in third second. So time of ascent is u by g. So 25 by 10, that is 2.5 seconds. So here third second journey means 0.5 seconds of upward journey and 0.5 seconds of downward journey. So here distance traveled in downward journey is half gt square. Time is 0.5, that is half whole square. 5 by 4, 1.25 meters. For upward journey, distance traveled in last 0.5 seconds is Distance traveled in 2.5 seconds minus distance traveled in 2 seconds. Distance traveled in 2.5 seconds is maximum height u square by 2g, 25 square 2 into 10. So that is 125 by 20, 25 by 4, 6.25 meters. Distance traveled in 2 seconds will be ut minus half gt square. So 50 minus 20, here it is, sorry, 25 into 5 will be there. That is here it is 625, 125 by 4. It is 31.25. Here it is 50 minus 20, 30. So distance traveled will be finally 31.25 minus 31.25. In upward journey and downward journey, total distance traveled is 1.25 plus 1.5, that is 2.5 meters. Here, position time graph is same as displacement time graph. Here, he given it as like this, but he is not asking asking distance. What you do is you find differentiate it, you get velocity because position time is same as displacement time. This is which implies velocity. So how do you get distance? By integrating speed. This is velocity. Speed means mod v dt. Covered in 4 seconds, that is 0 to 4. So which is 0 to 4 modulus of 2t minus 4 dt. 2 times 0 to 4 mod of t minus 2 dt. Integral 0 to 2 mod t minus 2 dt plus 2 to 4 mod of t minus 2 dt. Here it is integral 0 to 2, it is negative minus t minus 2 dt plus 2 to 4, inside 1 is positive, we write dt. Minus t square by 2 minus 2t plus t square by 2 minus 2t between 2 and 4. Here it is 4 by 2 minus 4 upper limit. Here it is 16 by 2 minus 8 minus 2 square by 2, that is 2 minus 4. 2 times 2 here, 0 plus 2. That is totally distance